Today I am discuss about the topic non-linear programming problem. The non-linear programming problem, first you discuss about Lagrange Lagrange method. The equality constraint, the constraint external problem, example Lagrange method. Lagrange method, the most common method of solving external problems having continuous differentiable objective function as well as constraint function with respect to the decision variable is the Lagrange multiplier method. The Lagrange multiplier method can be illustrated by the following simple two variable problems with one constraint. Maximize or minimize z equal to f of x1 comma x2 subject to g of x1 comma x2 less than or equal to b x1 comma x2 greater than or equal to 0. The constraint is replaced another function h of x1 comma x2 such that h of x1 comma x2 is equal to g of x1 comma x2 minus b is equal to 0. Then the problem now becomes maximize or minimize z equal to f of x1 comma x2 subject to h of x1 comma x2 is equal to 0, x1 comma x2 greater than or equal to 0. Step 2, the Lagrangian function L can be constrained as L of x1 comma x2 comma lambda is equal to f of x1 comma x2 minus lambda into h of x1 comma x2, where lambda is called the Lagrangian multiplier is a constant. The Lagrangian method constraint external problem with one inequality constraint. Use Lagrangian method to maximize the function f of x comma y is equal to xy subject to the constraint x plus 2y less than or equal to 200. Solution L is equal to xy minus lambda into x plus 2y minus 200. Dou L by dou x equal to y minus lambda of 1 equal to 0. Dou L by dou is equal to x minus lambda into 2 is equal to 0. To solve lambda is equal to y, then equation 3 and 4 to solve x equal to 100, y is equal to 50. Consider n minus 1 equal to 2 minus 1, that is equal to 1. Then delta 3 is equal to 0, 1, 2, 1, 0, 0, 2, 0, 0. That is equal to 0. Constrain the external problem with more than one inequality constraint. Therefore, the Lagrangian function can be written as L of x comma lambda is equal to f of x in the summation is equal to 1 to 3 assuming problem. Okay. Next one, another problem. Solve the linear programming problem by Lagrangian multiplier method. Minimum is equal to x1 plus x2 plus x3 subject to the constraint x1 plus x2 plus 3x3 is equal to 5x1 plus 2x2 plus x3 is equal to 5, x1 comma x2 greater than or equal to 0. Same procedure, first f of x, then x, then h dash of x, h double dash of x. Okay, the Lagrangian multiplier L of x comma lambda is equal to f of x minus lambda into h dash of x minus 2 times h double dash of x. Then the capital L value, dou L by dou x1 value equation number 1, dou L by dou x2 value equation number 2, dou L by dou x3 value equation number 3, then dou L by dou lambda 1 equation number 4, then x1, x2, x3 using equation 7 and 8 to solve the problem. Then another one topic, small topic is Kandaker condition. Kandaker condition constrain external problem with inequality constraint. This problem is maximization problem. Maximum z is equal to f of x subject to g of x is less than or equal to lambda. H of x is g of x minus b. Then another model is minimization problem. Minimization problem is z equal to f of x equal to x1, x2, etc. subject to the constraint g of x greater than or equal to b. And h of x equal to g of x minus b greater than or equal to 0. Introducing slack variable from the form a square, we have the problem as minimize z equal to f of x subject to h of x minus s square equal to 0. Following the analysis similar to the one use of the maximization problem, Kandaker condition becomes. Then another one problem, maximum z equal to 8x1 plus 10x2 minus lx2. Then to solve same problem to solve the maximum value. Thank you.